What are some of the branches of chemistry that you can remember? Organic chemistry. Thank you. There's also inorganic chemistry. There was also what? There are a lot of components of chemistry, right? Analytical chemistry. Yeah, a lot of things. But we're gonna focus on the organic chemistry. So, what is organic chemistry? Organic chemistry is a branch of chemistry that basically helps us to, just talk about this interesting atom, the carbon atom. So we're going to talk about carbon-containing compounds. Talk about their structures, talk about their bonding, how it gets to react and form different kinds of structures. Okay, so there are a lot of things that we're going to be talking about. Naming compounds, coming up with your formulas, being able to predict the reactions that these different carbon containing compounds have, of course, in relation to the hybridization that carbon can undergo. I'm sure we did chemical bonding. So we do understand that carbon can undergo 3 types of hybridization, which are what? I want some answers from you guys. Mm-hmm. So somebody says sp3. What else? What? Ah. uh, sp2. What else? Oh, interesting. Okay, so these are the types of hybridization that's. I think she meant the last one, which is like. This is like what? S denotes what? I don't even know what it denotes, ka? Okay. So, basically, how do you get to look at the hybridization? So, you get to look at the number of bonds or connections that carbon is connected. So, that's what determines the hybridization. And the fact that carbon has got 4 valence electrons, right? Do we understand that? Do we understand that we basically have 4 valence electrons of carbon? So meaning that these 4 valence electrons can be shared in different ways. There may be a case where there are 2 this side, 2 the other side, forming 1 bond, 2 bonds there. Then there may be a case where these gets to be 1 1 single, right? Where it gets to form 4 different bonds. Then there's also a case where it gets to form a double bond and 2 single bonds, right? 4 are already distributed there. Okay, so these are the different hybridization that carbon can undergo. So what are the examples that we can talk about? So examples is for methane, for example. This is an example of methane. So this one is what we're calling sp3. So we said you get to determine the hybridization by counting the single bonds, right? So you can say the first one is always going to be S. So P, P, P. So P3 is like the maximum. From P3 you go what we call D, right? Not so. You can go to sp3, D2. Okay. No. But for now we're going to focus on these 3 because these are the only types of hybridization that carbon can undergo. So there's sp3, there is sp, and then there is sp2. Okay, are we together? Is that fair enough? Okay, I'm glad we've understood what we're talking about. So a very good example is taking about carbon dioxide, for example. What kind of hybridization is that? What kind of hybridization is that? People are quiet. So you say, I said you count the first connection to be S, the other one to be P, right? So you have sp hybridization. So there may be a case where they ask you to explain the types of hybridization that the carbon atom can undergo. So you can say carbon undergoes the sp hybridization in a case where it gets to form two double bonds. Okay, two double bonds. So single double bond, two double bonds. So that is sp. Then the other type 1 is sp2, where the carbon gets to form one single double bond and two single. So a single double bond and what? And two single bonds. That is the case. This is the case where we get to have sp2. Then finally sp3, where it gets to form four single bonds. Are we together? An example is in methane. So these are the only hybridization that we expect carbon to undergo, even in our study of organic chemistry. Any questions so far? Do we have any questions? Okay, seems people have understood. So how far have you gone for those who've started? What have you talked about under organic chemistry? Have you already started naming them? Okay. What did you look at? Did you talk about the hybridization? Okay. What was your lecturer saying? Apart from what I've talked about? Or what was he reading? How do your lecturers present work? Do they just read the notes, see? Or they don't even, or maybe they come with projectors. These lecturers come with, they'll come with a projector. And then they'll just be reading the notes for you. Hmm. uh, so, okay. Okay. So cool. So as much as we can talk about this carbon in terms of its hybridization and whatnot, we need to understand that you can find it in different ways, okay? So there are going to be structures where you find it in a link form, for example, like that. Okay? That is the way it works. Have you seen that? This is actually wrong. I'm looking something. It's supposed to be something like this. Maybe you can have something like. So what you have that, you have that, you have that. So we are saying each carbon is supposed to form 4 bonds. So that's why I'm making 4 of them. Okay. So we are hydrogen atoms as well. So what is an example of hydrogen? If the way carbon can form. Sometimes it may be linear like that. Okay. So equally, we expect it to form 4 bonds, right? Are we together? Are we on the same page? Okay. So I'm saying there are going to be different cases. There's going to be a case where you may find it in a ring form, and also in a case where it is branched like that. Okay. So you may find another carbon down there. It gets to form like that. So now these are the 2 major ways in which you're going to find the carbon forming bonds in different compounds. So we get to classify them as aliphatic and what? Aromatic. So between the two, which one is aromatic? Is it the ring ones, the ring structure, or the straight and the branched? So aliphatic is straight. It may be with branches. Aromatic is a ring structure. Okay. Are we together? So I'll repeat again. For aliphatic, we're talking about something in this way, where the carbon are in a straight chain. It may have branches like that. As long as there's no ring structure there, it's aliphatic. But there are going to be cases where, like the one that I drew, where they're like that, where it's a ring. So this is aromatic. Is that difficult to remember? Is that difficult to remember? So aliphatic is also said to be acyclic, right? Implying that there is no cycle there. The other one is said to be cyclic. That's because it's a ring structure. Okay. Anything add about that? Okay. So if you talk about aromatic again, we are also saying aromatic, which is cyclic or ring structure, is usually formed on a basis of benzene. Okay. Benzene is basically a hydrocarbon which is made up of 6 carbon atoms and 6 hydrogen atoms. Okay. So come up with 6 carbons. If you want to draw it, 6 like that, like that, like that, like that, like that. Then make a double bond somewhere there. Single, double bond, single, double bond, single. Okay. Then add hydrogens where there need to be a fourth bond. So that one makes 4, 4, 4, 4, 4. Who understands how I'm counting, by the way? So in case you are missing it, we are saying each carbon has got 4 valence electrons. So it's supposed to form 4 different bonds, right? So if you look at the first carbon there, we have 1, 2, 3. So that one is the 4th one. This one as well, 2, 3, and 4. That's why I was counting 4, 4. So that's what we're trying to say. So you add the hydrogen atoms, making 6, right? So this is what we call a benzene. So now, you guys, we need to understand that there's going to be a point where we're going to talk about what we call skeletal structures under organic chemistry, where we would need to do away with showing of the hydrogen and the carbons in the link structure, or in the structures, in our structures. It may be in our aromatic compounds as well as the aliphatic ones. So for example, in this case, I can just show it to be like that. So wherever there is a 10, just know that there is a what? At every point where there is a 10, there is what? A carbon there. Are we together? And how do you get to show a double bond? We should get to show a double bond by drawing a line inside there. So that is a double bond. That is a double bond. Then this other double bond is going to be there. Are we together? So that is another way in which you can present benzene, implying that we don't need to show what? The hydrogens. Are we together? So we need to understand all those things, how it gets to move from a skeletal structure to come up with a formula. Are we together? What's so special about benzene? Benzene is basically like, it basically gives us an idea of what aromatic compounds are going to be like. Okay, it's a very good example of aromatic hydrocarbons. Okay, so even as you get to talk about, there's something that you're going to talk about under benzene. Okay, later on as we get to study the aromatic compounds more in details. So now, these hydrocarbons that we've started talking about, of course, if you talk about hydrocarbons for your own information, you need to understand that hydrocarbons are carbon and hydrogen containing what? Compounds, right? They are only made up of carbon and hydrogen. So usually they expect you to talk about these in two classes, right? They are what we call saturated hydrocarbons and what? Unsaturated hydrocarbons. So usually, like we've said, for a carbon to be satisfied or saturated, it needs to form how many bonds? 4 bonds, right? So in a case where you find that the carbon is not connected to 4 different atoms, it is said to be what? Unsaturated. Are we together? In a case where it is connected to 4 different things, it is said to be saturated. So the only saturated hydrocarbons are what we call alkanes. Are we together? So alkanes have got a general formula of CN H2N plus 2. So I don't want you to master this formula. Are we together? I don't want you to master it. I want you to know it. I want you to know how to come up with that formula. So we are saying saturated, it implies that all the hydrogens that we're going to have, all the carbons are going to be connected to 4 different atoms. Are we together? So for example, if I was to come up with 4, let me come up with 4 carbons. 1, 2, 3 and 4, right? All these are supposed to form 4 different bonds. So this one is already connected to 1 there, so I can add 3 more. 1, 2, 3. Again there, this one is connected to 2 already, so I can add 1, 2. Even that one, 1, 2 to make 4. The last one will need 3. So now, how many carbons do we have? We have 4, right? How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. So I'd want to come up with a formula to get a 4 appear on the other side. So it's basically C4 H 4 times 2 plus what? Plus a 2. So this can go. So what you just have N and what? N and 2N plus what? So that's a general formula. You can come up with a general formula like that. So where you say, okay, this is a 4. For it to become 10, it's supposed to be doubled plus a 2. So you have C4 H24 plus a 2, which is giving us what? A 10. So where there is 4, you can put N to come up with a formula. So you don't have to master for saturated, which are alkanes. Are we together? Where are you behind? On which part? Okay, are you okay mastering this formula? Okay. Yeah, so I was giving you an option in case you can't master it, so that you just determine it. by coming up with any saturated hydrocarbon by indicating the carbon atoms with 4 different bonds. Then write the number of carbons and the hydrogens that are there. Then show them in this ratio, smallest ratio possible. So saturated, I've said we call them alkanes. Then the other ones now are all classified to be unsaturated. So the first set is what we call the alkenes. So for alkenes, basically these, if the general formula is very simple, you just get to double them, right? Double the number of carbons. So if you have n number of carbon atoms, for the hydrogen it will just be double the number of what? The hydrogen atoms. Are we together? So by definition we can say, when you are talking about saturated hydrocarbons, these contains carbons with what? Single bonds only. There are only single bonds there. So a case where you're talking about something like that. That is an example of a saturated hydrocarbon, which is what we call methane. Then the other part where you have maybe at least a double bond or a triple bond. Whether there is a double or a triple bond, we refer to that as what? As unsaturated, because the carbon has got the ability of breaking the double bonds and being connected to other different what? Other different atoms. For example, if you talk about that, this is what we call ethane, which is the smallest unsaturated hydrocarbon of alkenes. So this is referred to as what? Unsaturated, because these carbons can still gain, and when they gain, that double bond will be split, so it will be a single bond there and a single bond there, coming up with this. So these are what we call reactions now. These are, so we call that as an addition reaction. Okay, where it gets to build now polymerization, in other terms, where it gets to gain hydrogens to move from alkenes to alkanes. So we're going to talk about all those reactions more in details. I'm just trying to give you an idea of what you need to know. Yes, madam. Yes. Unsaturated, I've got either a double bond or a triple bond in them. So they still have an ability of gaining more hydrogen atoms or any other atoms. So that's why they are referred to as unsaturated. They are not yet satisfied. If you can put it that way. Are we together? Okay. So we've talked about the different hybridization that carbon can undergo, right? We said sp. There is sp2. Just a minute. So yeah. Any questions? Is there any question? For the alkenes. So I said when you have n, you just get to double the what? And I said there's no need of you mastering these things. So for alkenes, are you saying alkenes or alkenes? So you're talking about alkenes basically. What did you say? You expect to have a double bond there, right? So we've shown a double bond there. So try to come up with a formula. How many carbon atoms do you have? You have 2, right? How many hydrogens can you see? 4. The basic idea is you need to make sure that each carbon is connected to 4 bonds, right? Which is the case for all these. So you've seen that it's just like the general formula is we're just doubling the number of what? We're just doubling the number of the carbon atoms there. Okay? Okay. So you guys, I need to watch football. Let me explain something before I go. Let me leave you with this. There are what we call types of carbons, right? Under organic chemistry. So we get to look at carbon by looking at the number of other carbon atoms that it is connected to. Are we together? So when you have a carbon like that, okay, okay, there may be that one. There may be a simple one like in ethane where it is just connected to the hydrogen atoms. Okay. There may be a one which is maybe in this kind of a compound. So it's at the end. Okay. And the one in between connected to three different ones. So this one is connected to, it's only alone. This one is only connected to one carbon. This one in between is connected to 1, 2, and 3. So now, there are what we call, there's what we call a primary carbon. Okay. There's what we call a primary carbon. So now, which one is the primary carbon? So now, let me discard this. It's not supposed to be part of that. So, a carbon which is connected like this one, a carbon connected to only a single carbon atom, and these other ones may be hydrogen atoms, is referred to as a primary carbon. Are we together? Then a one which is connected to three, like this one, 1, 2, 3, is referred to as what? So of course, if it's primary, you expect to have what we call secondary, right? A secondary one is going to be one which is connected to 2. Are we together? For example, a one like that one. A primary carbon is one connected to another single carbon. So a carbon connected to only one carbon is the primary carbon. A carbon connected to two carbon atoms, to two other carbon atoms, referred to as secondary. So this one is primary. So obviously tertiary would be what? What do you expect for tertiary? Tertiary is supposed to be connected to how many? So which is this? Which one? This one, right? So there are going to be things, guys, that we're going to start talking about. For example, we can talk about sec butane. It implies that you have a secondary what? Carbon in such. When you see tet, something like that, it would also imply that in such a structure that you're going to have, there's supposed to be a tertiary what? Carbon. That's why we need to understand what we are saying, the meaning of these. So when you say tertiary, it means that the carbon is connected to 3 different other what? Carbons. How about this one, which is connected to 4? So we said we have primary, secondary, tertiary. Then the other one is what? Okay, I'm sure we did talk about that. And is it in things like biology? I can remember very well my biology. Awesome. Okay. So I think these are the basics, guys, that at least what I've given you. Okay. At least I hope you have an idea. Then I'll work on a certain tutorial. Which I'll share to you by tomorrow morning, so that you can build up from there. So at next time, as we get to meet, we now need to start looking at the naming of compounds. Are we together? Naming of compounds, how to draw them, understanding the reactions that these alkanes and alkenes get to undergo. Okay, so just introducing the organic chemistry to you. Just make sure you check through your lecture notes. Are we together? Okay, so I hope you've learned something. Have a good night.